766. Man, Toeplitz matrix. Man, I probably did not say that right. But a matrix is Toeplitz if every diagonal from top left to bottom right has the same element. Now, given m times n matrix, return true if and only if the matrix is Toeplitz. Okay. Uh, okay. I mean, I think that's fine. Do I want to use Python? I guess I've been practicing Python. I could use a language if someone really requests it. Well, at least a language that I know. But actually, I think I'm going to use C++ just because I like the indexing a little bit better on dealing with stuff like matrices. But yeah, let's forget which one is which. Could this be 0? I guess I should have to check. Because if it's 0, then it's true by default. Yeah, okay. But yeah, I mean, I guess I didn't really talk about this farm before I dove into it because for Yeezys, I generally don't. I mean, I guess that's not always true, but at least for this one, I think it's just literally implemented directly, and you just kind of start with. At least how I'm thinking about it, just start with each matrix on the top row, and then just like walk through it using some mod functions and stuff like this. Uh, oh, I guess I have to do negatives. Maybe I didn't consider that. Uh, huh. Okay, but I still will stop on top row, and then I thought actually it would be like some wraparound type thing, but I guess not. And then I guess I'll also start from the top row and then the first column, and then we just go both, and that should handle all the cases, I think. So yeah. Is it M? No, it's N. So we start at cell I, or yeah, cell I. So now this is the offset. Let's start with K. K is less than M. I think. I guess it's just rows. So okay. Yeah, that should be okay. So if matrix of I starts at so the first element is not equal to the kth row is k plus I, return false, and we have to do some boundary check. K plus I is less than M. And K plus I is less than N. Okay. And now we just have to check first column. And also the default is true if you pass all the checks. So yeah. And I'm going to check the first element twice, but that's okay. I mean, we could actually change this. Also, now we want it to be M. So now we do I, and it's 0. And then we can actually just copy and paste a little bit, but not really, because now we want. Yeah, maybe I shouldn't have copy and paste, so I could force myself to think about it. Even though we could just modify that, but I think that's yeah, okay. So now we want to look at the first row, or the second row, but first indexed row, and make sure that that's less than n, and k plus I is less than m. So we start at, so that's the first element in the row. If it's not equal to yeah, k plus k. return false. Okay, I think this is good enough. Maybe. Weird. I think one thing I try to keep in mind when I do problems like this as well, and by problems like this, I mean when I look at the output, when it's binary, like in this case, it's true false. Um, I try to be a little bit more thorough because you can get lucky in the sense that you get the right, like it passes all your tests, but it's still wrong because your tests are just not good enough, and half the time it's going to be right or something like that. But um, but I think in this case it's probably okay. It's a much easier. I mean, this is a straightforward-ish problem. Maybe. Oh, look, there's hints. How nice. The only thing I could maybe think about is maybe I've been off by one in these edge cases, but yeah, in this case I'm okay. Okay, cool. Yeah, I don't know if there's that much to be talked about for this problem. I mean, it's just like it wants you to yeah, the problem wants you to basically go through the diagonals and you have to read every element once, so there's no like algorithmically it's going to be just m times n in time and no extra space other than like two variables, but or one extra space. Um, yeah, and then don't know if there's any weird tricky parts about this. Though with that being said, I think I've always run into problems with this stuff in the past where I have like weird off by ones. But I think with these, just try to keep it as, what's it called? Keep it stupid simple, and just do like the most basic thing of simulation that you can think of. I think another way I could have written this to be even clearer um, is just start with, well, one is probably just better variable names, to be honest. I probably uh, uh, could have done better than I and K. I could name this case is column and this is row and so forth and vice versa, so that it could make the understanding a little bit easier, especially when you need to debug. That comes in handy. Um, yeah, overall, I mean, you just diagonal it. Just check the diagonals, which you just have to check from the first one, the first column. Okay, cool. But yeah, I mean, I think these kind of simulation tests are pretty basic. Um, it's about 20 lines of code, and I feel like I've definitely seen, maybe not this one, but like random interview problems where people, uh, um, like some sort of simulation based on diagonals and like running through matrices. So definitely, I would consider this a problem that you could see on an interview tests. But yeah.